We start by defining sets. So what is a set? Set is a well-defined collection of objects. So say if this small s is an element, so element is also called object or member of this set capital S, we write it as S. You have this sign which means belongs to S. On the other hand, if S does not belong to this capital S, we write it as S does not belong to capital S. There are two ways to represent a set. You can represent it in a tabular form or a set builder form. So what is a tabular form? So in the tabular form, all elements are listed. So for example, the set of natural numbers, you write 1, 2, 3 and so on. So these three dot means that this list goes on forever. So this goes on forever. In set builder form, we write the description of the elements in the set. So you could just describe it as x such that x is a natural number. So let us discuss some examples. So we have already done example of natural numbers. So the second example could be solution set of this equation x squared plus x minus 2. Now you could factorize this equation as x minus 1 times x plus 2 equals to 0. You solve this, you get x equals to 1 or minus 2. So in tabular form we can write it as s is equal to 1 comma minus 2. So you could also write it as minus 2 comma 1. So note that the order does not matter. So you could write it as 1 comma minus 2 or minus 2 comma 1. It does not matter what order you follow. In set builder form, this is even simpler. You just write it as x such that x is a solution of x squared plus x minus 2. So this symbol is such that. So these two dots, when we write like this, it means x such that. So another example. So we are giving a set builder form. S is equal to x such that x is a letter in Mississippi. So in tabular form, you just write it as MISP. So note that the elements are not generally repeated in tabular form. So basically you could have written the set as MISSISSIPPI. So all the letters in Mississippi. So you could write all the letters in Mississippi. But we generally avoid a repetition. So there is M here, you copy M here, then you copy I here, and then you ignore the repetitions of I. So you ignore this I, you ignore this I, and you ignore this I because you have already written this I down. Then you write S, and then you ignore the S which repeat. Then you write down P, and you ignore the P's which repeat. Now we talk about equal sets. Two sets are considered equal if they have the same elements. So this set has 1, 2, 3, and this set also has 1, 2 and a 3, and you ignore the repetitions. So these two sets are equal, and this is not equal to natural numbers because natural numbers is more than 1, 2, 3. It also has 4, 5, 6, 7, 8, 9 and so on. So this is unequal. So this is unequal, and this is obviously equal. Now we talk about empty set. Now a set that does not contain any element is called an empty set. Sometimes this is also written as null set, and we denote it by this symbol. So for example, x such that x is an even prime number not equal to 2. So this is a null set because the only even prime number is 2, and we are saying that we want an even prime number which is not 2. So consider another example. x such that x is a natural number and a solution of the equation x square minus 1 by 4 equals to 0. So solution of this equation is x is equal to 1 by 2 or minus 1 by 2. So this is the solution of this equation. But this is not a natural number, and this is also not a natural number, because natural numbers are 1, 2, 3, 4 and so on, and half is not a natural number, minus half is not a natural number. And we wanted that x should be a natural number and a solution. So this is a null set. Now we talk about finite and infinite sets. Now a set which contains finite number of elements is a finite set. If it does not contain a finite number of elements, it is an infinite set. So for example, integers, this is infinite set. So this has an infinite number of elements. Now notice that it naturally contains this set of natural numbers 1, 2, 3, 4 and so on. So these natural numbers are automatically contained in integers. Another infinite set is this set of rational numbers. So this half and minus half are rational numbers. So 3 by 4, 1 by 2, minus 3 by 4, all these are rational numbers. Now if q is 1, then p by q is just p, and then this p is an integer. So rational numbers is p is an integer and q is an integer. Only condition we put is that q is an integer which is not 0. So this backslash here means it is integer z, this z minus 0. So this 0 is not here. So this is p, and so if q is 1, p by q is just p. This p is an integer. So these rational numbers contain integers. So these integers are contained within rational numbers. And these rational numbers are contained within real numbers. So real numbers contain all these rational numbers, plus they also contain irrational numbers like root 2, root 3, minus root 5 and so on. Now it requires pretty advanced mathematics to construct real numbers from rational numbers, but it is important to know that real numbers contain rational numbers. So this is a symbol for real numbers, this is rational numbers, this is integers. Now finite sets, we have already given a lot of examples, so just let us note them. So for example, this is a finite set, it has just 2 elements. So we are talking about finite set. Then this Mississippi, this is a finite set, this is a finite set, and the infinite sets are just these natural numbers, integers, rational numbers and real numbers, and there could be other infinite sets also.